Bourns is pleased to announce the release of a new AC surge protective device, the Model 1250A series, and a DC surge protective device, the Model 1420A series, which will significantly expand our current product line offering. Surge protective devices, or SPDs, play a crucial role in safeguarding equipment and ensuring overall electrical safety. By diverting excess voltage and current away from sensitive devices, SPDs prevent damage that could lead to equipment malfunctions or data loss. And by protecting the equipment, SPDs also enhance personal safety by reducing the risk of electrical fires and injuries. Moreover, installing SPDs translates to substantial cost savings, as they reduce the need for expensive repairs and replacements necessitated by surge-related damage. In commercial and industrial contexts, SPDs uphold business continuity by averting downtime caused by equipment failures. From shielding against diverse transient sources to fostering uninterrupted operations, SPDs prove indispensable in fortifying electrical systems. Transient surges, which pose a significant threat to electrical systems, can arise from a range of sources. Internal load switching, characterized by sudden load variations, can trigger abrupt changes in current flow and create transient surges. The impact of lightning strikes, whether direct or indirect, can extend several miles from the strike point as a transient surge, causing disturbances or damage to installations. Additionally, the act of switching transformers, motors, and other inductive elements, coupled with load variations and circuit breaker operations, introduces transient surges in the form of overvoltages that permeate buildings. Notably, a substantial portion of transient surges originate internally. A comprehensive understanding of these diverse origins is indispensable for effectively mitigating the potentially detrimental effects of transient surges on electrical systems. The fundamental principle of a surge protective device is to limit the voltage that is applied to electrical equipment and systems to a safe level during transient overvoltage events. As such, SPDs are typically installed at the point where electrical power enters a building or facility, such as at the main distribution panel or subpanels. They can also be installed at specific equipment locations to provide localized protection. SPDs contain one or more surge protection components, such as metal oxide varistors, or MOVs, and gas discharge tubes, or GDTs. SPDs with MOVs are often designed with fail-safe features. In the event of a catastrophic surge that exceeds the MOV's capacity, the SPD disconnects the MOV from the circuit, preventing the surge from propagating further. In a three-phase 277 VAC electrical power system, the ideal surge protective device model would be the 1250A-3S series. To ensure suitable protection, the voltage rating of the SPD, represented by its maximum continuous operating voltage, or MCOV, should be set higher than the system voltage. A 15% margin is typically recommended, which in this case leads to an MCOV of 320 volts. The surge current capacity, designated as I sub n and I sub max, should be determined based on surge protection requirements. As compliance with industry standards is vital in a protective device like this, Bourns SPD meets the requirements for both UL 1449 and EN/IEC 61643-11. A critical parameter is the protection level, often denoted as voltage protection rating, or V sub PR, and ensuring that the voltage across the SPD is lower than the equipment's withstand voltage. Surge protection devices offer versatile applications across various sectors. In commercial buildings, SPDs often safeguard sensitive electronic equipment, such as servers, where they avert damage from transient voltage surges. Industrial applications rely on SPDs to protect equipment like motors, ensuring uninterrupted operation and an extended lifespan. Telecommunication systems, including cell towers, benefit from an SPD's ability to shield against disruptive voltage spikes. Transportation systems, from railways to traffic control, utilize SPDs to prevent disturbances and damage. In renewable energy setups, SPDs play a pivotal role in safeguarding critical components like solar panels and wind turbines, ensuring equipment integrity and optimal energy generation. The Bourns Model 1250A Series SPD is a DIN rail pluggable AC surge protective device. The Model 1250A complies with UL 1449 4th edition and IEC/EN 616 43-11 standards, ensuring its adherence to stringent safety and performance requirements. It has impressively passed a short-circuit current rating, SCCR, of 200 kiloamps, and its reliability is ensured through a safeguarded metal oxide varistor, MOV, featuring an advanced thermal disconnector, TD+. This configuration provides superior protection against excessive surges and overheating. The SPD exhibits a substantial surge energy capacity of up to 50 kiloamps per mode, which is fortified by its pluggable module design, simplifying the replacement processes for enhanced convenience and efficiency. The 1250A series offers broader AC network coverage than the 1250 series SPD, accommodating a range of voltage configurations. This includes the 1250A-XS-277 variant designed for 240 over 415V or 277 over 480V AC power systems, and the 1250A-XS-600 model tailored for 600V Delta AC power systems. These variants ensure comprehensive surge protection for a wider spectrum of AC network setups, enhancing equipment safety and system resilience. The model designator, 1250A, signifies an advanced version of the 1250 series. The configuration, number of poles, is indicated by 4, signifying protection for 4 poles. The remote signaling capability is denoted by S to facilitate remote signaling. The operating voltage is delineated by numerical codes. 120 represents 120 over 240V and 120 over 208V. 230 corresponds to 220 over 380V and 230 over 400V. 277 covers 240 over 415V and 277 over 480V. 400 encompasses 277 over 480V and 347 over 600V. 480 signifies 347 over 600V and 480V delta, and 600 designates 600V delta. The 1250A series offers a range of configurations: single-pole configuration, two-pole configuration, three-pole configuration, and the four-pole configuration. These options cater to different needs, allowing users to select the configuration that aligns with the specific power system requirements for surge protection. The surge protective device can encounter failure modes that result in thermal runaway, potentially leading to overheating, smoke emission, and even the risk of fire. These failure modes include end of life. As an SPD nears the end of its operational lifespan, it becomes less effective at mitigating surge events, potentially allowing damaging surges to propagate through the system. Sustained abnormal overvoltage, or TOV. Extended exposure to abnormal voltage levels beyond the SPD's capacity can push it into thermal runaway, causing overheating and compromising its protective capabilities. Surge with unexpected energy. A surge event that carries energy beyond the SPD's design parameters can overwhelm its protective components, triggering thermal runaway and associated hazards. The significance of the TD+, Advanced Thermal Disconnector, in surge protective devices lies in its ability to ensure fail-safe and self-protection mechanisms, even in challenging scenarios. With TD+ technology, an SPD remains secure and reliable, even if the temporary overvoltage, TOV, reaches twice the maximum continuous operating voltage, MCOV. This technology's mechanical structure enables a permanent and secure disconnection from the power system. It not only prevents the SPD from overheating and entering thermal runaway, but also interrupts AC arcs and short circuits, mitigating the risk of fire hazards. By offering enhanced safety measures and greater resilience, TD+ technology significantly elevates the reliability and effectiveness of SPDs, making them a crucial component in safeguarding electrical systems and equipment. The Bourns Model 1420A series is a DC power surge protective device designed for photovoltaic system DC side protection against damage from surges caused by lightning and other electrical sources, up to rated limits, while operating up to 1500 VDC. These DIN rail mountable devices have a maximum lightning surge current rating of 50 kiloamps, 8/20th of a microsecond, per pole. This series is RoHS compliant, UL recognized, and meets UL 1449 4th edition requirements. The inclusion of high-energy MOV technology coupled with the Advanced Thermal Disconnector, or TD+, forms a robust defense system within the surge protective device. The device is also equipped with a status indicator, enhancing monitoring capabilities, and its modular design ensures easy replacement, streamlining maintenance processes. Operating effectively in both common mode and differential mode, this SPD provides comprehensive protection. The 1420A series stands as a reliable solution for safeguarding DC networks. Covering a broad voltage range from 48 VDC to 1500 VDC, this series offers protection across a diverse spectrum of DC network setups. Additionally, this series is available in 3 distinct configurations, ensuring tailored surge protection solutions for varying system requirements. This combination of voltage coverage and configuration flexibility underscores the adaptability of the 1420A series, reinforcing its role in fortifying DC networks against transient overvoltage events in both common mode and differential mode scenarios. The 1420A series presents a range of configurations to address diverse needs. Single protection configuration. This option caters to scenarios where individual protection is required. V configuration. Offering protection in a V-shaped arrangement, this configuration is designed to safeguard systems and provide the common mode protection. Y configuration. This configuration, forming a Y shape, provides specialized common mode and differential mode protection for setups demanding this unique arrangement. These configurations within the 1420A series ensure that various DC network setups can benefit from tailored surge protection solutions, enhancing system resilience and equipment safety. Ordering the 1420A series is a streamlined process with selection according to the following steps. 1. Model designator. 1420A signifies the advanced version within the 1420 series. 2. Application code. PV stands for photovoltaic, catering to solar energy applications. 3. Network voltage. Indicate the DC network voltage requirement with numerical values, such as 1000 for 1000 VDC. And 4. Configuration. Select the desired configuration to suit your setup. P corresponds to the single protection configuration, D signifies the V configuration, and Y represents the Y configuration. By following these steps, you can precisely specify your requirements and ensure that your selection of the 1420A series surge protective device aligns perfectly with your application needs. For more information on Bourns Model 1250A and 1420A series, check out our additional available resources through these helpful links. We appreciate your attention and look forward to announcing other products to you very soon.